inequalities with rational numbers. Remember, we have the symbol less than and fewer than. We also have greater than or more than. These are both open circles when we graph it on a number line. Okay, we also have less than or equal to, at most, no more than, and a maximum of. We have greater than or equal to, at least, no less than, and a minimum of. These are closed circles when you graph it on a number line. All right, let's look at example 1. Write an inequality. Twice a number plus 4 is greater than 2/3 of the number. So when we do twice a number, we have 2x plus 4 is greater than 2/3 of a number. Since we have a denominator of 3, what we're going to use is the distributive property to multiply everything by 3 to get rid of the denominator. So we're going to multiply both sides by 3. All right, so when we do 3 times 2x plus 3 times 4 and 3 times 2/3 x. Okay, here nothing can cancel out, so it's just 3 times 2, which is 6x. Nothing can cancel out here, so it's just 3 times 4, which is 12. And nothing, or we can cancel out the 3's here. So we're left with 2x. Now we have to isolate the variable, so we're going to get rid of the 6x. When we do that, we get negative 4x. And then we have to divide both sides by a negative 4. Now remember, when you divide both sides by a negative or multiply both sides by a negative, the inequality flips, so it's going to be x is greater than negative 3. All right, let's go to example 1. Write an inequality to represent the relationship, then solve your inequality. 3/4 of a number, so 3/4 x is greater than. Because it says is greater than, we know that that's going to be the inequality. So 3/4 x is greater than 5 less than the number. This is the less than here. This is going to represent the operation minus. But less than is a special situation. It is written backwards. So we're actually going to say x minus 5. Since we have a 4 in the denominator, we are going to multiply both sides by 4 to get rid of it. So we're going to say 3/4 x times 4, and we're going to say 4 times x minus 5. All right, so multiply both sides by 4. Multiply this side by 4. Okay, here the 4's can cancel out. We're left with 3x is greater than 4x, and 4 times 5 is 20. All right, we're going to isolate the variables, so we're going to get rid of the 4x. That's going to leave us with negative x. is greater than negative 20. However, you can't have a negative variable. So to get rid of the negative variable, you can either multiply both sides by negative 1 or you can divide both sides by negative 1. It's the same thing. So if we divide this side by negative 1 and divide this side by 1, this will become x. The inequality is going to flip, and we get x is less than 20. All right, let's look at example 2. It says 2 water tanks hold 28.62 gallons and 31.2 gallons of water. The larger tank is leaking at a rate of 12 gallons per hour. All right, so we have 2 tanks. We have a larger and we have a smaller. And when we're leaking, that vocabulary word tells us that that's a negative. So we have a minus 12x, and the larger tank would be 31.2. All right, and then we also have the smaller tank is leaking at a rate of 8 hundredths per gallon. So that's going to be 8 hundredths per hour. And we start off with 28.62. After how many hours will there be less water in the larger tank than the smaller tank? So less in the larger tank. All right. Oops, this is supposed to be 12 hundredths x because it was leaking at a rate of 12 hundredths. All right, I want to isolate the variable, so I'm going to get rid of the 12 hundredths x. So I'm going to add 12 hundredths to both sides. When I add 12 hundredths to both sides, I get 4 hundredths. And then now I got to isolate the constants. So I'm going to subtract. I'm going to have to borrow here. So I'm going to get 8, 5. So 2 and 58 hundredths. And then I'm going to divide both sides by 4 hundredths. Alright, so when I do that, I have 2 and 58 hundredths divided by 4. Can go in there 6 times. Can go in there 4 times. Decimal, decimal, 0. And it can go in there 5 times. So I have x is greater than 64 and a half hours. All right, let's go to the next one. Bamboo plant A is 1.2 meters tall and is growing at a rate of 4,500 hundredths meters per day. So we have plant A. The constant rate of change is 45 meters per day, and we start off at initial of 1.2. Bamboo plant B is 8,500 hundredths meter tall and growing at a rate of 0.5 meters per day. All right, so After how many days will plant B be taller than A? B has got to be greater than A. So we want to isolate the variable. So we're going to get rid of the 4,500s. Alright, so we're going to get 500s. Then we want to isolate the constants. So we're going to get rid of the 8,500s. We got 3,500s. Then we are going to divide both sides by 500. So when we have that, we have 3,500 divided by 500. It's going to go in there 7 times. So x is greater than 7. So plant B will be taller than plant A after 7 days.